Hello there, wonderful and esteemed viewers on this wonderful mathematics YouTube channel, Mathematics by Aguzena. That special channel created for you and I to come together to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. Today promises to be interesting as we are resuming a brand new topic, a topic that cuts across general mathematics as well as further mathematics at the ordinary level. This topic is so interesting that it has several aspects of it, and I'm talking of no other than sequence and series. Today we are looking at the introductory aspect of the topic sequence and series, whereby we shall be distinguishing between the terms sequence and series. Today we are going to find out if these terms can be interchangeably used, as is often the case by most learners. What is sequence? What is series? And we're going to look at examples, illustrations of terms that distinguish one from the other. And finally, we're going to take a work example of what a typical question under sequence and series is for the introductory level. So to start with, what is sequence? And then what is series? Sequence, loosely speaking, is a set of terms, subsequent terms, such that there's a constant pattern, and with that pattern we can generate the future terms. In other words, there's always a pattern in the terms of a UB sequence, and with that pattern gotten, we can easily predict, quote unquote, subsequent or future terms. This basically is what sequence is. On the other hand, what is a series? In simple English, series is simply the summation of the terms of a sequence. And when we say summation in mathematics, it could be any of addition, subtraction, and or a mixture of addition and subtraction. So in other words, series is simply the summation of the terms of a sequence. So we have, for example, let's have on this side our sequence, and here the series. As defined earlier, sequence is a set of numbers or values that follow a particular or regular pattern through which we can generate the subsequent terms. And where some sequences are very easy to obtain, some might be a bit difficult. Let's say, for example, you have 2, we have 5, we have 8, we have 11, and so on. If you look at this, we have the numbers 2, 5, 8, 11, and so on and so forth. A very savvy individual with numbers, we know that, okay, these are necessarily terms increasing by 3s, plus 3s. Plus 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11. So that plus 3 is a constant there. It's a constant pattern. And since we know there's a constant pattern, we can use that to generate the next term, which is simply going to be 11 plus the same 3, which is 14, plus 3, 17, and so on and so forth. That's quite easy. If you have the lesson, for example, we have 12, we have 10, we have 8, we have 6. Here as well is a sequence of numbers reducing in value by a constant value. We have here 12 minus 2 is 10, minus 2 is 8, minus 2, 6. That means we're having a constant of minus 2. So from that, we can generate the next numbers to be minus 2, 4, minus 2, 2, and so on and so forth. We could add, say, 4, 12, 36, 108. In this case, there's also a pattern, a constant pattern, and that pattern is times 3. Plus or minus, you know what it is. 4 times 3 is 12. Times 3, 36. Times 3, 108. So that means the constant pattern here is multiplying by 3. And so on and so forth. However, some might not be that straightforward. If I have, for example, 1, 4, 9, 16, 25. This type of sequence might not necessarily be addition or subtraction or multiplication, not even division. So you have to think deep and see this as what? Squares of natural numbers, starting from 1. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. That means the constant pattern is the square of natural numbers. So after having gotten the constant pattern, we can easily predict the next number, which is going to be 36, which is 6 squared, followed by 49, which is 7 squared, and so on and so forth. So enough of that. Let's have a look at some that might be very difficult to get. Let's see how this. So we have this. This is a bit similar to this. This is simply the cube of natural numbers. 1 cube is 1. 2 cube is 8. That is 2 times 2 times 2. 3 cube, 27. 4 cube, 64, and so on and so forth. So, as you can see, by definition, a sequence is a set of numbers or values that follow a constant or regular pattern, and through which we can generate the subsequent terms. In other words, once you can identify the pattern at play, we can then use that pattern, the knowledge of that pattern, to generate the subsequent terms. That is what sequence is. What then simply do we mean by series? As I said earlier on in the intro, that series simply means the summation of the terms of a sequence. In other words, we simply replace the commas with plus or minus or both. So we can have here 2 plus 5 plus 8 plus 11 plus dot dot dot. No more comma. So this becomes series. You can see the difference. Sequence. They are the same numbers, 2, 5, 8, 11. But the comma being replaced with plus or minus, as the case might be, turns this from sequence to series. Similarly, here you have 12, you can have minus 10, minus 8, minus b2. And here we have 4 plus 12 minus 36 plus 108 minus, so that's a mixture, and so on and so forth. So we can see clearly the difference between the terms sequence and series. And that basically is the distinguishing explanation of the two terms. So you might be pardoned if you use them interchangeably, but technically speaking, therein lies the difference. Then there are a lot of sequence and series, quite a lot of them. We have a lot. To start with, we have what is called the alternating series, we have the P series, we have the negative series, we have the harmonic series, we have the exponential series, we have the Fibonacci sequence and series, we have the Maclaurin series, we've got the Taylor series, on and on and on. However, for the purpose of the ordinary level, general mathematics or further mathematics, we shall be restricting ourselves to just two, and these are the arithmetic progression, popularly called AP, or also linear sequence, and the geometric progression, popularly called GP, or exponential sequence. These are the types of sequence and series we shall be restricting our classes to in the coming videos for the O level. The other ones I mentioned earlier are for advanced level mathematics. So let's dive in and look at a typical example of the question under sequence. The question goes thus. The nth term of a sequence is given as Tn equals 4 Tn minus 1 minus 3. If 12 5, the third term is 5 times the second term. Find the fourth 3 terms of the sequence. Okay. The question goes as follows again. The nth term of a sequence is given as Tn equals 4 Tn minus 1 minus 3. If twice the third term is 5 times the second term, find the first 3 terms of the sequence. So this sequence particularly is an anonymous sequence that got no special name as such. So let's get used to that. So to start with, we use what we have. We always go from the known to the unknown. We know for sure that the term for the sequence is given. So, then from the question, twice the third term. The terms mentioned are third term and second term. So let's generate the second term. So second term by formula, we say T2, that's second term, the n stands for the term. T2 equals 4 T. Remember, if n is 2, that's 2 minus 1. T1 minus 3. That is T2. Okay, then what is, we are requesting an expression for second term, T2. What about the third term? The third term is actually T3 equals to, using the same formula, that is 4 T 3 minus 1, T2 minus 3. And bearing in mind that we got our T2 earlier, we simply substitute the values for T2, the expression for T2 here. So this becomes 4 T2 is what? 4 T1 minus 3. So the value parenthesis stands for T2, which is actually 4 T1 minus 3, then minus 3. Note the multiplication of 4. There is 4 for T3. Now, T2 has its own 4 T1, then minus 3. So this gives us, open the bracket, 16 T1 minus 12 minus 3. And that is 16 T1 minus 15. That's our T3. So we have expressed both the second term and the third term in terms of the first term, which is T1. So we know this, that's T2 and that's T3. Now we now go to the information. Twice the third term is 5 times the second term. It says twice the third term. Twice, 2 times T3. That's meaning of twice the third term. Twice the third term is 5 times the second term. Is 5 times the second term. Hope you can see that coming out. Twice, that's 2 times the third time, T3, is 5 times the second term. So all we need to do now is to replace all the values in terms of T1s. Hence we have what here? 2 was T3, 16 T1 minus 15 equals 5. What's T2? 4 T1 minus 3. So everything is now in terms of just T1. We open the bracket and we have 32 T1 minus 30 equals 20 T1 minus 15. Collecting like terms in terms of T1, 32 T1 minus 20 T1 equals minus 15 plus 30. This is actually going to be 12 T1 equals to 15. From there, we have T1 equals 15 over 12. So you divide further, that's 3 goes there, 5, 3 goes there, 4. Hence, T1, which is the first term, is actually 5 over 4. Remember, as you're asked to get during the first 3 tests, that means the first 3 times means T1, T2, and T3. So we've gotten T1, that's the first. To get our T2, remember, T2 is given here as what? 4T1 minus T3. So our T2 will be then 4. What's T1? The value is 5 over 4 minus 3 by the formula. Hence, 4 cancels 4, we have 5 minus 3, which is 2. And that's our second term. So T2 is 2. Then lastly, what's the third term? Again, the formula is here to rescue us. So you have 16. What's T1 again? 5 over 4. Then minus 15. So 4 and 16 is 4 times 5. 20 minus 15. And that is 5. So in conclusion, as the question says, find the first 3 terms of the sequence. The first 3 terms are T1, T2, and T3. These are the first 3 tests, and they are numerically 5 over 4, 2, and 5 respectively. And that's the solution to that interesting introductory example on the topic sequence and series, which I believe you found quite interesting and fun as usual. And I believe you found this class as educative and enlightening as possible. If you do, as I expect, please don't forget to subscribe, share, like, comment, and important, and tune on your button so you'll be the first to know when our next video is dropped. So the summary, the topic has been introductory aspects of the topic sequence and series. We've been able to distinguish between the term sequence and the term series. And in summary, we are saying that series is simply the summation, which means addition, subtraction, or mixture of both, of the terms of a sequence. What then is a sequence? Sequence simply means a set of values or numbers that follow a regular or constant pattern through which we can generate future or subsequent terms of the sequence. And that has been the lesson today. Thank you for staying tuned. God bless, and hope to see you in our next video when we go properly into arithmetic progression AP. Thanks.